Hey everyone, Mr. Washam here, and we're going to get started with our first set of notes on chemistry. And so we began today's lesson by talking just about, what is chemistry? And we talked about that at the separate tables, and students came up with different answers. And a lot of the answers that tend to come up, over and over again are things like, chemistry is dealing with chemicals, or it's a part of science, or you mix things in test tubes and stuff like that. And then students are always really disappointed when I tell them, hey, we're not going to blow anything up. And then we actually get to the actual definition of chemistry, which is that, it is science, and it deals with the composition and properties of substances. And so we kind of break that down really quickly, and we say that the composition is what the substance is actually made of. And the properties are things that you could name or see or list, characteristics of that substance. And so then we get to the word substance, and I say, well, substances are really just like things. So can somebody give me an example of a substance? And somebody will say water. And water is a substance. And so what's the composition of water? And somebody will say, well, water is H2O. Well, what's H2O? Well, H2O is hydrogen and oxygen. Okay, so that's the composition of water. It's made of hydrogen and oxygen. And can you tell me a property of water? And of course, water is liquid. And so that's a great property of water. And then we say that to round out that definition, that it's in various forms. And so there's basically three forms of matter: solid, liquid, and gas. There are some additional forms, things like plasma, that you would learn about later on. But as far as this class, we'll stick with solid, liquid, and gas. And so since chemistry is the composition and properties of substances in different states of matter, well, what exactly is matter? And so matter is anything that has mass and takes up space. And by space, we mean volume. And so when we talk about the first word in there, mass, generally we use, something like this right here, triple beam balance, to find mass, which is not necessarily the same thing you would use to find weight. We're used to stepping on a scale and there's a number that appears, and we call that weight. But remember, weight is just simply gravity pulling down on you, and that can change from place to place. If you go like to the moon or to Mars or to a different planet, your weight would change because you'd have more or less gravity. But the amount of stuff that you are that would sit here, and as we move these and we find your mass, that would always be the same. So mass is kind of like the amount of stuff that makes you up. And when we talk about space or volume, there's two ways to measure volume. So the standard way, if something is a solid, you can measure its length and width and height or thickness. And you would do that in centimeters, and you would get something called a centimeter cubed. However, if something was liquid, you'd use something more like this, a graduated cylinder. And on the side, you notice there's a whole bunch of numbers, and it's in milliliters. And so each one of these little numbers is equivalent to a centimeter cubed. So if you had something that was 1 centimeter, 1 by 1 by 1, that's the exact same volume as having just one of these numbers in liquid form. And so that's how you would measure volume. So matter is anything that has mass and takes up space. So can you name for me things that are made of matter? And of course, and in class, we say, hey, that flag hanging on the wall, or my phone, or me, you, a car, our Chromebooks that we're working on. And eventually we learn that, well, hey, matter is everything. Everything is made of matter. Well, if everything's made out of matter, then what exactly is matter made out of? It's got to be made out of something, right? And sure, the answer is atoms. And so everything essentially is made out of atoms, which makes up matter, which is, why we come to this, never trust an atom, because they make up everything, right? So we get to atoms. And then we come into class and we say, well, atoms are the smallest particle that there is, but there's actually three smaller particles, something called a subatomic particle that's actually smaller than the atom. And so we talk about those three particles, and those three particles are called the electron, the proton, and the neutron, and they each have a different charge. So the electron is a negative charge, and the proton is a positively charged little particle, and a neutron has no charge at all. And so these three particles, a proton, an electron, and a neutron, if you put them together in the right combination, you would make an atom. And then, of course, an atom would make matter. So what we have to kind of organize all of this is we have what I've came up with called the matter pyramid of science. And so the matter pyramid of science is arranged in a pyramid with the smallest thing being at the top and working its way down. So the smallest thing is the atom. It's the smallest particle from which everything is made. And as we work down, all atoms, they make up stuff called matter, which is anything that has mass and takes up space. And then matter can be arranged into two different areas called a pure substance and a mixture.
In regards to the guideline tryouts, ladies, they are posted all.
And so, pardon the interruption there. Matter is anything that has mass and takes up space, but that matter can be split into two different categories, one being called a pure substance. So a pure substance is composed of only one type of atom or molecule. And so just that one atom, it makes it up. Or it can be in a mixture. And a mixture is easy to see because it's a bunch of different stuff that's mixed together. It's not chemically combined. You can separate it back out. A good example I use to represent a mixture would be when you do the dishes at home, you put all your silverware in the dishwasher. But when you take it out, you probably separate out your forks and your knives and your spoons into the drawer. So matter is split into one of those two categories. And then from there, our matter is split even more. So if you're a pure substance, you can either be an element or a compound. And so an element is basically can't be broken down into anything simpler, like you have hydrogen and oxygen and helium and nitrogen. And of course, all these things I'm listing are just elements, and they're elements from the periodic table. So all known elements on the periodic table would be good examples of elements. Sometimes elements combine together, though, and when they do combine, they create what's called a compound. And so compounds are more common. There are way more compounds out there than there are elements because the elements can combine. And so some examples of different type of compounds would be things like water, hydrogen and oxygen combined together, makes water. Table salt and sugar. These are all examples of where elements have came together and they have made something called a compound.
Mark Moore, Desmond Helvey, please come to the front office for a message. Mark Moore, Desmond Helvey.
And more interruptions. Sorry about that. And then homogeneous. If it's not a pure substance, it's a mixture. And so mixtures are split into two different types of mixtures. You have a homogeneous mixture, homo meaning the same. And so these are mixtures that are evenly mixed.
Jenna Adams, come to the Student Center. Jenna Adams, come to the Student Center for.
And anyway, some examples of homogeneous mixtures, since you can't see the different parts, homo meaning all the same, would be something like salt water. If salt and water was mixed together, if you've ever been to the ocean, you can't see the difference. Another example is juice. A lot of your juices is some sort of concentrate mixed with water, but once mixed together, you can't see the difference. That'd be an example of a homogeneous mixture. And then finally, the last type would be hetero. Hetero meaning different. So these are substances that are mixed together, but when they are, you can see the different parts. So a great example of this would be like trail mix. It's a bunch of different substances, raisins and peanuts and candies and stuff like that, but you can see all the different parts. Other things that are finer, sometimes sand, you can see the different particles that are mixed together in sand, and even different types of gravel that are mixed together. You can see parts that are in there with the gravel. So this is our matter pyramid of science, and how things are arranged from smallest to largest. But it all starts with the atom, the smallest particle from which everything is made. And so that is our first set of notes for chemistry. Have a good one.